Good morning, everyone. Welcome to the last day of Tableau conference. I hope you enjoyed it. Thanks for joining me for this early morning session. My name is Bora. I'm a product manager at Tableau Software, and we'll be talking about how you can achieve different goals using analytics and different tools that are available to you. So let me start explaining what this session is all about so we have the expectations set right. Knowledge is of two kinds. We know a subject ourselves, or we know where we can find information upon it, said Samuel Johnson, and this was in 1775. Today, at the age of internet, this is even more true. As long as you know what you're looking for, the right keywords, you could find anything you want on Google. So what I'll try to do in this session is, instead of trying to teach you very specific things, I will start by listing different goals. Here's our analytic goal. Let's say do a forecast on top of a moving average, which today you can't do in Tableau. Then I'll show possible solutions. So what I want you to take out of this session is, oh, here's a technology I heard of. This is something I can apply to my own problems. So more about exposing you to the art of the possible, relevant technologies. So when you leave this room, you either find new sessions that might be of interest based on the new topics that you learned today, or next time you hit a similar problem, you know what Google keywords to use to get there, if you have a list of things you want to learn in Tableau, you add some of these topics to your list. So it's more of an exposure thing, and you will see a lot of code. I'm warning you ahead of time. There will be SQL code, there will be R code, there will be R code inside SQL code, and there will be often fine print. And the reason for that is I don't want you to read the code. I'm sure some of you will try. I'll see people squinting. The goal is not really the code, and you will have access to all the content. So you can read the code after if you want to, but the idea is understanding the general concept. Because you can apply the concepts with different pieces of code because you may not have the exact same problem. It's the concept that matters. There's going to be so many topics I'm covering. If you wanted to do a thorough job of talking about all of them, it would probably take me 6 months to go through everything. So again, don't read the code, don't worry about the details. It's all about understanding the art of the possible and how we can solve specific problems with certain methods inside Tableau. Okay, so when you're solving an analytical problem in Tableau, there could be many different ways depending on the scenario you have and the type of data you have. Maybe you can't put the data into Tableau because it's unstructured or it's too large, and depending on the scenario and your data, you may end up using different methods. So let's start by going through all of them. First is in database analytics. So let's say you have really large data and you don't want to move everything over the wire in a Tableau. Instead, you want to push the calculation to the database. So that's a great scenario for in-database analytics. Or your database might have special capabilities. Certain databases have spatial capabilities, or they can do machine learning inside the database, and you want to take advantage of what your database has to offer. The second option will be preprocessing. So take the first example where we talked about large data sets inside the database, but make it much larger and add some computational cost of doing transformations. Let's say it takes an hour to run some analysis. This is not something you would want to do in real time while you're working with the data in Tableau because the performance won't be great. Nobody wants to wait with a spinner for an hour. So that's the perfect scenario for preprocessing. You may want to do batch flows, run them overnight, create a data source, and then Tableau just goes ahead and connects to that data source. And the last one is local calculations, by which I mean just things that you do natively inside Tableau. It could be aggregates, row-level calculations, table calculations, etc. And this is more valuable when you want interactive flows. Maybe you don't want to write SQL or MDX or anything like that. And maybe the database doesn't have the functionality you want. If you want to do a running sum, for example, your database may not have a function to do a running sum. Or one of the databases you have this function, but you're doing a cross-database join with 3 tables, and you want to use all of the data in the analysis, then you can't rely on a single database. So all of these are good examples, use cases for local calculations. So let's start with in-database analytics. And again, I'll set a goal. That's how the flow will go. Then we'll explain how to solve the problem and repeat this formula. So our goal is doing a forecast over a moving average. If you try to do something like this in Tableau, probably you're a bit confused because forecast gets disabled the moment you have a table calc. And this is because the forecast and table calcs don't blend together. So there's a solution to this, and that it lies in pushing this calculation to the database. So in this case, we're going to be looking at specific technologies of custom SQL and raw SQL. And in SQL, some databases offer this thing called SQL analytical functions, or windowing functions. And that's where we're going to do our moving window calculation, allowing us to do forecast on top of it. And depending on the database, these could be running totals, ranks, moving averages, etc. So let's start with an example. First, what is custom SQL? If you connect to a relational database like SQL Server, Oracle, Teradata, etc., where everything is flat tables, you will see an option called Custom SQL. On the screen, you will see it at the very bottom under the list of tables. And you can just drag it into the view, and the moment you do that, you will get a little pop-up dialog where you enter your SQL. So here what I did was, and I'll try to use different vendors to be equal distant from any one of them. So here you're seeing in Oracle SQL, I wrote my window calculations. And what it is doing is it's doing a moving average for a fixed range. It says rows between 3 preceding and the current row. But I may want to take this a step further and expose controls to my user so they can say, well, I want a 20-day moving average. I want a 5-day moving average. So I'll just go ahead and add some parameters to it as well. As you know, parameters could be exposed inside Tableau, in your dashboards, in your sheets, where people can interact with the underlying structure. So let's put this all together in a dashboard, in a visualization. And here you can see now I am able to add a forecast bill because it's not a table calc anymore. It's being pushed to the database, and it works fine. And I have my sliders here following 2 preceding 3. That makes it a 6-day moving average, including the current data point. So if there are things that don't blend in Tableau, you should look for ways whether you can push that calculation somewhere in the database, hence work around a limitation like this. Let's take another scenario. Again, we're going to rely on our database, and you're trying to do spatial analysis in this case. And you have some store locations, and you want to do a radius search. What are the customers within 5 miles of this particular store? So in this case, we're going to still use custom SQL, or raw SQL in this case, and we'll rely on this thing called user-defined functions in the database. So user-defined functions, as the name implies, are extensibility methods inside each database. And a lot of major databases have them. Even NoSQL databases like Hadoop have UDFs. And there are many ways these could be authored, so they could be really powerful. You can write them in Java, you can write them in C++, or you can write them in SQL. So you have a lot of computational power at your fingertips. And what a lot of the vendors do is they also use their own extensibility to add advanced functions. Let's take SQL Server, for example. If you use SQL Server Spatial, it is a UDF written by a SQL Server team using their own extensibility, just like you could do it yourself. So that's what we're going to do for this demo. But it's good to define what type of UDFs exist. What we're going to use now is called a scalar UDF. It's like a row-level calculation. You take one value, you take another, gives you another value. There are aggregate ones. They're like sums inside Tableau, but you could write custom aggregations. We'll have an example of that as well. And analytical window functions that we talked about. And finally, table-valued functions, where you ask a question, instead of getting a single row back, you would get a full table back that you can do a select from. So let's write our first raw SQL. Here you can see raw SQL is actually a type of calculation in Tableau. You can see it in Calculation Editor if your data source supports it. You're not going to see it in extracts currently, but hopefully in the future. And you start with raw SQL, and you will notice that there are multiple types of raw SQL functions. In this case, what we're using is raw SQL bool, because this calculation, this SQL script, will give us a Boolean. Tableau has no idea what happens between those quotation marks. So you have to tell it, this is going to return a Boolean, this is going to return an integer, this is going to return a float, this is going to return a string. So if you type raw SQL autocomplete, you will see there are all these options for different types of data that it's returning. So let me highlight what it is doing here. So we have 2 inputs to this SQL script. It is using the intersect function that is built into SQL Server in this case. It is taking locations, which I'll show you a table of, and it's taking the radius. So it's taking the location, it's creating a buffer around it, so giant circle growing around it with the given radius, then that is a polygon. And then we'll do an intersection between a polygon and the data points you have. Whatever falls into that polygon, it will return true. Whatever is outside it, it will return false. Hence giving you this is it within radius kind of filter that you can use. And as you can see, since I'm passing 2 parameters, %1 maps to the location, %2 maps to radius meters, and you can have as many of these as you want. Just follow the order and increment % number. And here's my location. It's a parameter, and I put my store locations as point coordinates in there. And we'll combine this all together and see what it looks like on a dashboard. Here is the interactive version. I can select a location and immediately see all the customers around that within that range. And I can also slide and adjust the radius that I desire, which will give me immediate feedback. And again, we don't currently have all these spatial capabilities in Tableau. You're solving the problem by saying, oh, my database has this capability. Can I offload it? And it's always a good question to ask when you hit a roadblock in Tableau. Is there any way my database can help me solve this problem? Because the reason we added functions like custom SQL and raw SQL is not everything is possible with point and click, and sometimes you may want to write code to work around some of these. So let's move on to a simpler problem. And this is something probably you all ran into. The asterisk that nobody wants to see. It doesn't really tell you much other than there are multiple things in that bucket. So here's the problem, right? Oh, it's a little too fast. So I do this, and I have a chart for each line is a market, and I want to see what product types are sold within each market for each line. And you use an adder, and what Tableau gives you is this asterisk. Wouldn't it be nice if it gave you a comma delimited list of everything that was sold in there? I think that's probably what everyone wants to see instead of an asterisk. Well, this is something you could do using this function called raw SQL ag. It is the same idea as raw SQL. Again, you have to say, is it a string? Is it a Boolean? Etc. You pass the arguments the same exact way. The only difference is instead of using a row level calculation, you're using an aggregate. And you're defining a custom aggregate, in this case in MySQL, which has a function called group concat. And you want to get the distinct names of all the fields that occur here in product types in this case. And you want to concatenate them into a line. That's your aggregation. You're taking however many rows you have, doing count distinct essentially under the covers, and putting a delimited list. And what this will give you is this, which is exactly what you want. And here, all the things, product types, are being sold in West, region West. So it is good to think about how you can take advantage of your database's power to write custom aggregations. You could be aggregating in different ways. You could be doing weighted averages. You could be doing other types of summary functions. OK, so everyone is following, I'm hoping. Am I going too fast? OK, looks good. OK, awesome. So far, we talked about mostly aggregations or row-level transformations. So you have a table, and whatever you do does not significantly change the shape of the table. But there could be operations where you go from unstructured data to structured data, or use pivoting or unpivoting your data. And these are fundamental changes that are not things that you would want to do in your data pane as a calculation after the fact. So let's say you want to pivot your data. So you pivot meaning you have a long table, and you want to make it a wide table. Take things that are in rows, make them into columns. So here's my original table on the left. I have some survey results where the different questions in the survey are in rows. So stated interest is one question I asked. Estimated interest is another question I asked. They voted 9 and 8, and they're repeated for respondent ID. Let's say for some reason I would want these questions to be independent columns. So that's a transformation in the shape. And in this case, for the sake of this demo, I'm also adding a timestamp to show you what you could do with Initial SQL, which is our next tool to use for this. So Initial SQL is a technology we support on certain databases, and here's a list you could see, and there are limitations based on the type of the database. For example, the first 4, you can embed parameters, and as you saw in my previous demo, parameters will give you the ability for your end user to be able to change things and trigger a refresh based on those new parameters. On the right-hand side, you cannot pass parameters. The only type of parameters you can pass are things like usernames, et cetera, and it's typically used for security reasons. So let's use Initial SQL, but start with talking about where you can find this option inside Tableau. So the moment you log into, try to log into a database, you get this authentication dialog, and you will see a hyperlink that says Initial SQL. And you can start typing right in there. But if you miss this and you don't want to go into that dialog because you don't want to enter password, another way of getting to it is under the data menu. You can find initial SQL for that specific data source if it is supported. Right there. So this is, again, our input, and we want to shape this data. And I'll write this initial SQL just like custom SQL with one major difference. So in custom SQL, if you used custom SQL, you'll notice that if you don't have a single select statement that returns a table, Tableau will complain because it can't query it directly. With initial SQL, you don't have that limitation. You can have as many different commands as you want because Tableau will just run through them without expecting any return. It doesn't expect a table. It doesn't expect anything. And in this case, just to demonstrate the fact that you can have multiple statements, I declared a variable for date time. I set the value of that the current date time, even though it doesn't really serve any purpose for the demo pivoting. It just shows you can stack up as many steps as you want, and Tableau will just run through without complaining. So in this case, let me highlight important parts. I set my current timestamp, as I was saying, to make the point that you can have multiple statements in there. Then I'm doing my pivot operation as highlighted in there. Again, this is something my database supports. I know that it supports it, so I can freely put it in there. And finally, you have to create some table for Tableau to read from, and that will be where the results of this transformation will be stored. In this case, it is a temporary table indicated by the hash sign in the beginning. And this is a session scope table. So the moment you disconnect, it will automatically disappear from the server. Your database admin doesn't have to worry about it. The second thing is, it is on by default in SQL Server. They can't even stop you from doing this. So it is a harmless thing. You can do this on your own without asking for permissions from anyone. So we do our major shape transform. We write everything into a table. Now, what I need to do is have Tableau read from this table. Remember, it's called demo temp. So I'll rely on our friend from the previous slides, custom SQL. I'll drag it in. I'll say select star from demo temp, which will read everything from that demo temp table the initial SQL just created. So one good thing about initial SQL is it runs only once at the very beginning, hence it's called initial SQL. So if you keep querying the data, it's not going to try to pivot every time because it already did it. It created a table. So it will be much faster than running the full pipeline. Of course, you can force it to run every time by hitting F5 and hitting refresh. But typically, a lot of people use initial SQL for really heavy data processing, something you don't want to do over and over again. That could take, let's say, a minute to do. So it is really powerful that you could just do it once, and the rest of your queries won't be impacted by any of the just pre-processing performance issues. And again, here's my result. I can see my current time. Apparently, I did this demo last year at 1:44 a.m., and here's the pivoted result. OK, so we talked about the power of writing these functions and how some databases allow you to do things in C++, in Java, and R. Let's take this one more step further and look at something slightly more complicated than just SQL. You want to run daily sentiment analysis on Twitter data. You get the data, you do sentiment analysis, and somehow read that from Tableau. So in this case, I know my database has this functionality where I can embed R code. Again, reminder, please don't try to read it. The goal for this session is to expose you to different concepts, not to teach you exactly how to write R code. So in this case, it's SQL Server, and as of 2016, they allow you to embed R code in your queries, which is what I'm doing. And I'll highlight certain parts of it. The first part is, again, the same trick we used in the last example, initial SQL, where you have to create a table where you can store the end results of your transformation. So create that table in the very first part. The second part is where my R code starts, where I first say, here are my connection information, my credentials. I've deleted them for this demo to connect to Twitter and get the data. And one thing we're doing here is we're getting the current date and just getting stuff since the current date, because we're going to take advantage of this as a scheduled job on Tableau Server, so we can get every night the previous day's Twitter data, just the previous day, and do sentiment analysis on it, hence having this moving window calculation as opposed to trying to get all the data at once, which will be a lot, the former will be a lot more performant because you only get a small subset of the data. And the last step is taking those and converting into sentiment, so we can have sentiment scores associated with all the tweets. And then I write all of the results into the table we created in the first blue section of the slide. And one thing to have this moving window happen is you create an incremental extract, right? So you do the same trick again. You created a table, you do a select star from the temporary table, but instead of doing a full extract, you say, I want this to be an incremental refresh. And you say tweet ID is my unique identifier. That's how Tableau will know it has not seen that tweet before. And every night this will trigger, and the timestamp will be the beginning of that day because we're rolling up to the beginning, and ask Twitter, what has happened since the last time I ran this query? Just give me those new tweets. I'll do sentiment analysis. And since this is incremental extract, Tableau will just take that data, append it to an existing extract. So every day, maybe you get 100 tweets, and you just keep adding. And over time, you will accumulate thousands of tweets. The nice thing about this is processing 100 tweets will take less than a second. If you wanted to do your entire 10-year history of tweets, it will be much longer. So there's the benefit to incremental extracts there. And another benefit of this is you don't need a second tool to do the processing and scheduling for you. The moment you say, I want this extract refresh every day on Tableau server, all of this pipeline will run for you automatically. And that's your incremental refresh. So we talked about initial SQL, custom SQL, and UDF so far. Let's move on to something somewhat different technology called stored procedures. With stored procedures, your common goal is you want to almost create parameterized tables. Like with a table, people connect to it, they get whatever data in there as long as your row-level security permits them. But in some cases, maybe you have large tables and you don't want people to get all the data. So you want to prompt something to ask them, okay, if you're a sales area manager, first tell me which sales area, which region is your area, so I'll only show you the data for that. The other nice thing about this is if you use a stored procedure, you could write really complex logic that you can't do otherwise. You could have loops, for example, in your SQL, which typical SQL doesn't allow. You could be calling out other things. So there's a lot more you could do about it. So stored procedures is something we added to Tableau probably about 3 years ago as a native concept. We support it on a limited set of databases where you can just drag drop these things. But if you think about everything I did so far with initial SQL, technically, if we don't support initial SQL for your database, you could always run it, try to put it into a temp table, and query that temp table. So I gave you a workaround for lack of support if that happens to be for the database that you have. But if we do support it, things are a lot easier. You just drag it in. Here you see a list of stored procedures on, again, SQL Server in this case. And I can drag it just like a table. And the nice thing is Tableau will treat it like a table, so it can join with other things as well. And if there are required parameters, which are sometimes the case with stored, which is sometimes the case, we'll pop up a dialog. We'll ask you to provide those. In this case, I have 2 parameters. You say, I'm looking for all the stores above this latitude, and it has to contain the following letters. So this query will run. It will give me a subset of my data. And again, you're enforcing some constraint on the end user. And some other databases have similar concepts. They call prompts, et cetera, or parameters, as opposed to stored procedures. So far, we talked about in-database analytics. That was the first bullet item I had at the beginning of the session. Now, how about we move on to pre-processing, where typically your data is large and there's no real-time requirement, so you can do batch processing overnight, et cetera. So let's go through the cases where this might be necessary or desired. You might have foreign file formats. Some of these may be familiar to you if you're in the science domain or if you're doing deep neural nets, et cetera. For example, NetCDF and HDF5 are these binary hierarchical formats that compress really well. And it's common in some industries to use them. But Tableau can't read them, so you have to convert it to something Tableau can read. That's a perfect pre-processing step. Or you have certain imagery data or like raster grid formats Tableau can't read, but you can run some pre-processing and turn it into a table Tableau can read. The second one is unstructured data. You may have log files, tweets, et cetera, where you actually want to extract a structured table out of it so you can read it from Tableau. And last one is more generic answer. So regardless of the shape, if your data is really large, it's going to take a long time to process the data in real time. And you really don't have any sense of urgency. I can run this overnight. I can run this at the end of every fiscal year, and that is sufficient. Well, it's probably the right thing to do. Just run it once, put it inside a data source, much more performant, because you're not trying to do heavy lifting on the fly as Tableau is querying the data source. So there are multiple ways of doing this, and I call them pull and push. In this case, there are slight differences, and some of the tools actually overlap. So there are two tools that allows you to productionalize their pipelines. These are ETL, extract, transform, load tools, and turn them into web data connectors. So web data connectors, as you know, are things you can directly query that will give you an extract, and they could be parameterized. And Alteryx and LavaStorm are two such partners that allow you to do this. And I'm not going to go through the details of demoing the products, but I'll give you a quick overview of how this would work in Alteryx. So in Alteryx, you will see there is this gray button, WDC for Tableau, and that could be a sink where you can put at the end of your pipeline. So the pipeline runs, and the output becomes a web data connector. You'll just drag it in, and it will give you something you can publish to your Alteryx server. And when you search for it, you will see the connector. This is what you would type into your web data connector screen in Tableau. It will take you to Alteryx server, and you could see the demo script in there on that list. And once you pick it, it will tell you the parameters. Just feels like a stored procedure example I had in this case. You type it in, and then it will create you a Tableau extract, running that entire pipeline for you. So you're pulling it on the fly by running the pipeline dynamically. The other option is more of a pool model where somebody decides, so I'm going to create the CSV file, or I'm going to write things into a database, and Tableau should just go read it from there. And there are a lot more options in this scenario. You could see like there are so many tools that can write CSV, so my right-hand side is quite full. A lot of the data science tools are able to either create Tableau extracts or CSVs. And we also natively support R, SPSS, and SAS files if you want to use their native formats. Or you can write in the database, as we did with the initial SQL example, right? Create something, a table that you can read from. Okay, so we talked about all these. I am able to create a data source, but we always relied on some technology on some fancy database. Imagine you don't have the funding to have a fancy database, whatever that particular database might be. Or you gamble too much while you're here, you had funding you don't have anymore. So let's take an example where you don't have access to these tools and how you can get to the same result using open source and free tools. You can download this example from my blog. I have all the details in there. And again, you will have access to all this content as well. So you could put together a pipeline by yourself using three common tools. You can have a Python or R script. In this example, I'm using Python. You could use Tableau extract command line utility that will allow you to take the output of Python script and append it to an extract on the server. And you need something to trigger this to run every night, every hour, whatever you desire. And there are many options there. I did this on Windows. I use Windows Task Scheduler. But there could be cases you're on a Linux machine or Unix machine. You can use cron as an alternative. So how does this work? First, you need to get the data. I have some Python script to get that data using Twitter API. And then I have my command line utility, how I call command line utility at the bottom. You can see there are some blurred out areas that are my credentials. And I'm just saying Tableau add file to extract. And here's a CSV, and here's the name of the data source you're going to append to. And that CSV called myFileCSV, if you could read from the back, is something my Python script is creating. So I first run my script, scrape Twitter, do my analysis. In this case, is tokenization. So I have multiple tokens. Each word becomes a separate entry, and so I can build a word cloud. And then the second step takes that CSV created by Python and appends it to my Tableau extract. It's the same process we talked about. We were doing it in the inside database earlier with embedding the R code inside database. But if you don't have the database that can do that, here is an alternative solution. And here is how you schedule it. This is Windows Task Scheduler. You just create a new task, say run it every night, and here's a script you need to run, and you will have a pipeline free, essentially. So we talked about how you can create data sources, but another way to go about this is creating workbooks, because workbooks can have data sources, and sometimes you want more than just a data source because you might have some templates you want to apply. You want to build this end-to-end flow where you push a button, it creates you some Tableau workbooks following the template, using the right data sources you want and all the pieces in there. And of course, we have partners that do these as well, programmatically or using data flow tools. So Alteryx and LavaStorm, again, we talked about it earlier with web data connectors, and you could just generate workbooks and make that as a sync at the end of these flows, and they will create workbooks for you. So far we talked about everything you could do outside Tableau and how you consume the results of those from Tableau. But as I said earlier, there are cases where you may want to rely on local calculations. And one of them is, of course, well, you showed me all the SQL and R. Well, I don't really want to write SQL. Because that's why I bought Tableau. You should be writing a SQL for me. Well, if you want to do that, we have several options, as you know. For example, we have the built-in calculations that you can access. We have a long list of calculations if you look at the help. And some of them are row-level calculations like date diffs, et cetera. And we have aggregate calculations. And we have quite flexibility around aggregate calculations. A simple aggregate would be a sum of sales or average profit. You can write level of detail expressions, which we have lots of sessions about in this conference, where you can specify at what level you want to aggregate something or multiple levels of it through nesting. You can have table calculations, which allow you to do a lot of moving calculations or multi-level aggregates. And finally, there's a more visual way of doing these things like totals, ref lines, trend lines, et cetera, where you can just drag drop to get the results you want. But sometimes, again, you may want to do more than what we offer because it's really hard to please a data science audience, if you might have some in your teams, because they can say, well, this is how we differentiate. I can't use a tool out of the box. You can give me clustering, but I want to customize every detail myself of the algorithm because we're a hedge fund. I have to beat my competition. It has to be very specific. So for that, we added integration with R, Python, and most recently MATLAB. R, it's been about almost 3.5, 4 years. It was in 8.1. Python, we added in 10.1. It's almost a year ago. And MATLAB, we added in 10.4. It's been 3 weeks or so since we released it. So depending on what release you have, you probably have access to, I'm assuming, at least R. And we will talk about some examples of how this works. I'm not going to get into detail again. These are like placeholders, something to keep in your mind. If it addresses a problem that you have, you can find other sessions. You can read more about it offline. But I'll touch on all of these languages with small examples to give you an idea of how it works and how you can leverage it. So with R, Python, and MATLAB, we don't natively process the code into Tableau. Tableau actually does not know anything about Python or R or MATLAB. We will use another component where we pass the data from Tableau to that external service, we call it, which will process the script because it knows how to interpret R or Python, and it will just give us some column of data back that we can display inside Tableau. Since we have this dependency on a runtime of R or Python, you need to install a separate component. For R, this component is called rserve. And again, it's open source, a free R package. If you use R, you just type install packages rserve and you have it. I run rserve and Python server all on my laptop. It doesn't drain much battery. I can demo them side by side. So they're called servers, but I think that's a really loaded word. It's not really heavy like Tableau server. You can easily run on a low-end laptop without any problems. So that's rserve. For Python, we added our own component called TabPy. It's called Tableau Python Server, which you can download from our GitHub repository. And again, if you just install TabPy, it takes less than 2 seconds to install. It's really lightweight. And again, it manages the data and Python script coming from Tableau, going into Python, and how the results come back inside Tableau. And finally, MATLAB, in this case, it is not open source. As you know, MATLAB sells licenses for their product. You need to have this thing called MATLAB Production Server, where you deploy your models, do your development in MATLAB console, and then Tableau can use those models by passing data and getting results back. So first, you need to connect to these services that you have, that you install in your laptop, or it could be a separate machine that your IT provided to you. by going through this step, and you go under Help, Settings and Performance, and Manage the External Service Connection. This will pop up a dialog where you enter the name of the server. If it's running on your local machine, it's localhost. If it is on a different machine, you can put the IP address or the host name and the port number, and now Tableau knows where to send those requests to get answers from those languages. So here's a quick example that shows you how it works. And you will see two windows here. One is a table calculation window because the calculations that we send to R and Python are always table calculations. On the left side, you will see how the formulas themselves are structured. So in this case, what you're seeing is I have a function called script real. And again, it's really similar to what we do with raw SQL examples that you've seen. Tableau has no idea what happens between those quotation marks. Same as SQL, we take that, pass it to R, it gives us a response. Since we don't know what it does, we don't know what it's going to return. You have to pick the right function. Script real if it's returning a floating point, as in this example, which is correlation coefficient, it's a floating point number. If it's returning a string, you will do a script string. If it's returning a Boolean, you do script Boolean, and so on. Here, what you're seeing is I embedded some Python code right into Tableau's calculated field. That import numpy as np return np core coef is all Python code. Of course, there's a need to pass columns of data into Python or R. And I'm using this example because it works exactly the same way Python or MATLAB doesn't matter. So I have two arguments in this case, and I highlighted that sum of sales maps to underscore art1, and sum profit maps to underscore art2. Those are in red. You can have as many columns as you want that you can pass to R, Python, or MATLAB. You just need to follow this ordered syntax where if you add a third one, it will be referred to as underscore arg3 inside your code. And Tableau will package this, send it, the object of data and the code, and get results back. Oh, so since it's a table calc, if you're familiar with table calculations, there's this concept of addressing and partitioning that's in play, which is what you're seeing on the right-hand side. In this case, I check the box customer name. That means I use that for addressing. Again, if you don't know much about table calculations, this is kind of for you to think about it, maybe something you may want to learn in the next Tableau conference or on your own time. But by not checking category and segment, what I'm telling Tableau is I want to partition my data by combinations of those two. And if you used our table calculation dialog, you could see that highlighting kind of guides you on what it is doing. So I have a window of data. Everything else is grayed out because these settings tell me that that's the only computation I'm going to do. Then I'm going to repeat that calculation for each of those windows. As a result of which, I get different correlation coefficients for each of the panes. I could check all of those boxes. And if you're familiar with table calculations, that means the entire table will be one partition because I'm not dividing by anything. Then all of those values will be exactly the same because even though you are visually partitioning the data in your chart, you're passing all data to get single correlation coefficient from Python. So all of those settings matter when you're doing calculations inside Tableau with R and Python and MATLAB. So here's an actual working example. In this case, we're trying to find criminal hotspots in Seattle area. There are many thousands of points in this case, and we're trying to narrow it down to interesting areas where maybe police wants to increase patrols. And this is somewhat similar but different from what you saw in the keynote and devs on stage because you can actually define what is a hotspot. You could say, well, the events have to be within 100 feet of each other. There has to be at least 10 events per quarter. And by that definition, Tableau will run the algorithm that you're seeing here and give you the results. And one thing to highlight here is, again, this time I have 4 parameters and lots of code. We don't have any limit on how many lines of code you can put, what Python packages you can use. If you can run something inside Python and R, since we're just passing along the script to Python and R, and don't make an attempt to interpret it, it means you can run it inside Tableau because all the heavy lifting is done by R or Python, not by Tableau. With R, I wanted to show a different example because the previous one is a binary classifier. Is it hotspot or not? But you could do a lot more than coloring things or filtering things by it. In this case, I'm doing overlay curves and going a little fancier on the right-hand side. The first curve that you're seeing in the upper left corner is the sine curve. So I have these data points. I want to fit a sine curve to it. A lower one you see is a logistic curve. And on the right-hand side, I'm doing a multivariate kernel density plot. which you can imagine to be a two-dimensional version of the bell curve. And since we have two dimensions, it's a volume that I'm displaying, and the blue areas would be the top of that curve where most of the population lies in the middle, and the things around the edges, the red areas, would be likely outliers, unlikely points. So it is a really nice visual way of doing it, and again, all of those areas, shaded areas, are generated by R. And the code for that is not that complicated. Here's the example for the one on the right-hand side. There's a kernel density function, KD to 2D in this case, and R. I'm just passing my data, generating this interesting plot. And you could do even more, and we talked about cases that are more descriptive. We talked about predictions, predictive analytics. You could also do the so-called predictive analytics using all of these tools. And in this case, I'm using MATLAB to demonstrate that point. A common question in prescriptive analytics is you're asking the tool to tell you the optimal way of doing things. Like, what's the optimal stock portfolio? What's the optimal way to traverse these locations if I'm traveling between them? And here our example is the so-called traveling salesman problem, where you have some locations that you want to visit, and you want to understand what's the best way of what order to visit them to maximize and do it faster, save gas, or whatever our target is. What you're seeing here is actual airports in the United States, and you're asking Tableau to tell you in what order I should be traversing them. And if this is not a problem that can relate to, a more relevant example could be like USPS or FedEx trucks. Every morning, they have to figure out what order should we deliver these packages to save gas. And you have the addresses instead of airport locations. That's a very similar problem to solve. There could be other constraints that you may want to put on, the weight of the vehicle or location of the distribution facilities. So this could be a much more complex problem. And one thing to see here is, as I said, we offload everything to MATLAB production server, and the coding happens inside MATLAB. Hence, you see these two windows where all the code is in MATLAB. What Tableau does is calls this endpoint called getLatLongVector, which is a service running on MATLAB production server. So you cannot embed code like you do with R and Python in case of MATLAB. So we talked about all of these things. You're running things inside the database using R, Python, or C++. In some cases, you're sending it to these server components. But there are cases where you don't want to necessarily install an R server or Python server or have database capabilities. But you still want to do the so-called scoring operation inside the database. To describe what scoring is, let's say you train a machine learning model that will help you predict the churn, the attrition, the fraudulent activity. So you train the model based on historical data. Now your goal is take that model, apply it to your new data where people have not churned yet or they haven't quit yet, but you want to predict the chances that they will ahead of time. So the last part where you get the scores, the probabilities of some event happening, is called scoring. But luckily, there are ways you can run these predictive models depending on the type of the model right inside the database. And I'll show you how to do it using two methods. So first one is one of our partners called BigML, and you can actually train a model. In this case, what you're seeing is called a decision tree, and there will be an option in this picture. It's the green selected option, export to Tableau calculated field. Since a tree is essentially a bunch of decisions, it turns it into this large if-then-else set of statements, where you can copy-paste that into a Tableau calculated field, and now you're running a machine learning model, in this case a decision tree, inside your database that has no idea about what machine learning is, because it's translatable to something that could be expressed in simple SQL. As with everything, well, if you don't want to buy something, you want the free version of it. I also have a free version. You can get this from my blog. I wrote these functions where you can pass an R model, and it will automatically give you a Tableau calculated field for that model. It works with decision trees. That's the first example. I'm training a decision tree using R part package. And we're trying to predict miles per gallon. It's OK, bad, and good based on model year and the maker of the car. And sadly, if maker is American and model year is less than 79, it's bad MPG. Well, it's probably the muscle car era. You really don't care about MPG, and the gas is cheap. But you can copy-paste this right into Tableau. And since it's an if-then-else statement, you can run it on any database you want. It will just work. The second example I have here is a different kind of model. The first one was a categorical result. In this case, we have continuous results, a probability of something happening. The very specific example is trying to find the probability of a student going into grad school based on their GRE score, GPA, and the ranking of the school. That is, like, if it's a good school like MIT versus not such a good school, that has an impact on their chances of getting in there. And again, I take this logistic regression model, I run my formula regression model to formula, and it will give me a Tableau calculated field I can copy paste, and I can use it for scoring. And logistic regression is a really commonly used model for binary classifications like the fraudulent activity, et cetera, that we talked about. So, and since we're talking about regression, if you try this function, you will also be pleasantly surprised that you can do multiple linear regression as well, and if you have interactions between multiple terms, it will also discover those too. So I have about 14 minutes left, and I would like to leave some room for questions. So I'll try to summarize the things we have gone through and list some keywords if you were to look for these on Tableau's website or do a Google search on it or find relevant sessions next year or later today about those. So first, we talked about taking advantage of database capabilities for data transformations or advanced calculations. The relevant terms in this case are raw SQL, initial SQL, custom SQL, SQL analytic functions, user-defined functions, stored procedures, common table expressions, which you can run as part of initial SQL if you want to. Then we talked about creating data sources ahead of time. And tools we used for this was incremental extracts, Tableau command line utility to do add file to extract, and Windows Task Scheduler or cron to create schedules so these run on a certain cadence that you desire. You could, of course, do these things in Project Maestro, which is our new product currently in beta, or partners like Alteryx Informatica or LavaStorm. And finally, we talked about analyzing your data in real time without relying on what your database can do. And these were level of detail expressions, table calculations, grand totals, reference lines, R, Python, and MATLAB integration. And we have really good sessions on many of these topics at this conference, and I'm sure there are going to be plenty of sessions next year. We also have lots of content on our wiki pages and blog posts, et cetera. You can visit the Expo Hall to find more about some of the partners I mentioned as part of my talk that offer these technologies. They will give you details on how they work. And please complete the session survey so I know how well or terribly I did and try to do better next year. And here's my contact information. Thank you very much. So if you have any questions, I think there's a microphone, and I'll be happy to answer them in the next 10 minutes. I can repeat it, but the microphone is right there.
So I'm a novice with R. I've used it a couple of times. One challenge is the code in R and the code in Tableau that you put to go to R are different. And it's not very intuitive how to change it. Mm-hmm. Do you have any suggestions on how to get that understanding?
Sure. So the way we handle our code is we expect to get a column of data back. And we expect it to align with the data that you sent to R or Python. So it works really well for things like classification, where you send, here's 10 people, tell me which ones will churn or not, because you get 10 classification results are yes or no. And that will work exactly the same way. You can just copy paste from R or Python and it will work. But there are some problems like forecasting where you actually want to add more rows because you're forecasting out 5 years. That means you have to create extra 5 rows. So there are examples of this on my personal blog where I showed how you can use forecasting packages. Tableau has this concept called densification, where you can generate rows on the fly in your data, which is also the technique I use for that two-dimensional kernel density plot. So you can create extra rows to make room for it, but there's a little bit of code that you have to put in your R script to handle the nulls generated by it. But if you go to my blog, you will find tons of examples of how to work around those limitations. And some of the things what we would like to address in the future is, as you know, in Tableau data source, everything is a single column. Every entity you see is a single column because it is modeled after tables in SQL. Right? There are no complex objects. So this has an impact on how we run R or Python. We expect a single column back, which is something we would like to address in the future. So if you have, let's say you're doing a prediction and you want to get the mean prediction plus the upper and lower prediction intervals, then you'll have to make 3 calls to get each of those as separate columns. So those are the limitations that you should be aware of. And your code should be able to handle those for it to work.
You mentioned briefly that Alteryx could create Tableau workbooks, and I didn't really understand what you meant. I was wondering if you could just explain that a little bit more, or maybe give an example.
So Tableau has this API that allows you to update parts of workbook, but we haven't gotten around to actually giving you an API that allows you to create full workbooks. Some of our partners went ahead and reverse engineered the workbooks by looking at the XML. So they found a way to create TWIBs and TWIBXs as part of their pipelines. So that's what they're doing. I create a data source, and you want me to create something, put it in a TDS or TWB, I can do that for you as well. So they're just generating the XML for a workbook.
On this side?
Oh, sorry.
A great presentation, by the way.
Thank you.
On one of the examples, you had the example of the traveling salesman. It looked weird that it was average longitude and average latitude. Is that just because you have to send in an aggregate for that field?
That's a great question. So as I was saying, all of the script calculations are table calculations. And the way table calculations work in Tableau is they all have to be aggregates. But that is just a syntactic thing, because our calculations react to level of detail changes. Right? You can drill up, drill down. I have to figure out how I go from your row level data to whatever level of detail the view is. So we're requiring you to write average sales, sum of sales, something. But in that view, all of the airports were single rows. So I could have put anything I want. It wouldn't matter. And if I really want to pass row level data to R in Python, there's always this option in the analysis menu where you can uncheck aggregate measures. And even though your formula says sum, you will be passing row level data, and that will be completely ignored.
All right. Thank you.
Mm-hmm.
Hey, hi. Do you have a write back option? Is any of the one of the two?
So yes, there's a write back option, but I wouldn't recommend using it through this, because you have, we probably seen a demo of the FreeLard, the extensions API. That's the internal name we use for it. That will probably be the better option. But since you're writing R or Python code, and they all have packages that allow you to write CSVs, and R has this package called RDBC. If you want to do an insert into a database, you could also do that. So that will give you the option to do a write back. One caveat is if you use something like R and Python, since they're table calculations, we rerun it every time you make a change to your filters or level of detail. So by accident, you may be inserting the same row multiple times. You have to embed the logic to say, do I already have a record that matches this? If it does, don't insert it, because it will keep running it every time you make a change in your view.
Hello.
Hey.
I have a question. As far as the Tableau API, I understand you do have, external partners, vendors, et cetera, that has decompiled it. The question is regarding the workbooks itself. Is it possible to take a workbook, decompile it, and generate into documentation for someone who really doesn't have any clue about what the report originally was?
So I'm not the right person to answer that question. I can put you in touch with the PM who owns our APIs, Ben Lower. He was on Devs on Stage, and he can give you more details on what is possible today and what's on the roadmap. That will probably answer that question better.
Cool. Thank you.
Mm-hmm.
The initial SQL, is that honored on the server, and does it run at every refresh?
So it is honored on the server. One thing on the server is your admin may enable or disable it for security reasons or performance reasons, but it does run on the server. And it's going to run, if you force refresh, it's going to run again. And every time you open a workbook, it's going to run for the first time. Yes.
Hi. Can you run rserve and tabpy together? And if so, if I call script int, for example, how does it know what to execute? Tableau or Python or R?
Currently, what you need to do is you have to pick one, because we only allow one configuration. You could have 2 different Tableau workbooks, and they could have different settings because they're different windows. But when it's a Tableau server case, you have to pick one of them, or you have 2 Tableau servers. This is something we would like to address in the near future. We would like to pop up a dialog and tell you, oh, here are some R and Python servers that I know of when you're trying to publish to the server. Then you could say, oh, Tableau server, please pair this workbook with this, this server. So as you're uploading it, we're linking the 2 by saying this workbook is running on R, another workbook could be paired with Python. But currently, yes, we make an assumption that there's only one, hence there's no way of specifying it.
We currently use the R server quite extensively. Is there any advantages of moving to Python?
Well, there are multiple answers to that. Some people find Python easier to learn because it's more like a programming language as opposed to R that was meant for statisticians. So if you have a preference, that might be one way of thinking about it. I hear from a lot of customers that they think Python is more production quality and it performs better, it scales better, etc. So we have customers who actually initially develop in R by their data science team, and then somebody goes and ports them to Python, and they use Python in production if they want to do things like scoring. So those will be 2 points to consider. I think that's it. Well, enjoy the rest of the conference. Thank you. Thank you.